Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, this is Mr. T, and we have a tutorial today on solving rational equations. Let's get into it. So let's talk about the procedure. Our objective is going to be to multiply the equation by a particular expression that will eliminate all the fractions. That'll make the equation easier to solve because we'll be using our skills that we've learned in Algebra 1 for solving linear equations or quadratic equations. So to accommodate that, what we need to do is find the least common denominator of all the denominators on both sides of the equation. So if you remember from when we did the adding and subtracting rational expressions, we want to factor each denominator and determine the LCD. We're going to take each of the unique factors in all the denominators and put them together to form the LCD. We'll review that when we go through the examples. Once we've determined the LCD, and we'll keep the LCD in factored form, we're going to multiply every term on the equation all the way across on both sides by the LCD over 1. So we're going to multiply every term even if it's not a fraction. Algebra allows us to multiply both sides of the equation by a particular expression as long as it's the same on both sides and we don't change the equation. The benefit is when we simplify each term, all the denominators are going to cancel out, so no more fractions, so we have an easier equation to solve. So as stated before, we'll use, depending on whether it's a linear or quadratic equation, the appropriate technique. Now, one possibility when we use this method is that we get something called an extraneous answer. So it's an answer to the equation where we canceled all the denominators. So it will answer that equation, but it won't be an answer to the original equation sometimes. And the way we determine if it's extraneous is we take each of the answers we find in step 4 and plug it back into the original equation and look, will it cause any of the denominators in the original equation to equal 0? Now remember, we can't divide by 0, that's undefined. So if any of these answers do cause a divide by 0, we throw it out because it's an extraneous solution. So here's our first example. So we're going to factor the denominators. So if we factor 6x squared, 6 factors into 2 times 3, and then we have 2 x's. We have a 3x, which can't really be factored, and we have an x squared. So remember, our rule is to take each unique factor, so a 2, a 3, and then when we have x's, remember we take the highest power. So our LCD is 6x squared. So we're going to multiply. I'm going to write the original equation, and next to each term we're going to multiply it by our denominator over 1. And when we have a subtraction, we're going to move that minus to the numerator and turn it into an addition problem. Notice we're multiplying both sides of the equation by the same thing. Now in each of these terms we're going to simplify. So 6x squareds cancel out, so we have 1. Here, one of the x's cancels out, and the 3 divides into 6 times, so we have 2x here times minus 1. Over here, the x squareds cancel out, so we have 6. So now this time we have a linear equation. There's no exponent on the x, so we're going to get the x's on one side of the equation and then divide, and we get x equals negative 5 halves. Now we check, if I put negative 5 halves into these denominators, it will not cause any of them to be 0. The only value of x that would cause these denominators to be 0 would be 0. So that's not one of our solutions. So This is good. This is not extraneous, and that's our answer to number 1. Okay, let's look here. So our denominators, if we factor them, so our first denominator, we can factor out an x, GCF factoring. Our second denominator, we can factor out a 3x. And our last denominator, we can factor out a 3. So our unique factors, we have a 3, an x, and that. So when I rewrite the problem, I'm going to write the denominators in the factored form that we had for each denominator. Makes it easier when we go to cancel things. And remember, we're multiplying by the least common denominator over 1. This was 3x squared times 5x plus 3. Oops, not 3x squared, it was 3x, my bad. And that is our LCD, so that's going to cancel out. And this last one at the bottom factored out a 3. Can't write today. Let's fix that. That's really ugly. And again, times our LCD. So here, the x and the 5x plus 3 canceled out, so we're left with a 3. So we have 3 times 2 is 6. Here, the whole thing cancels out. We're left with 1. And here, everything but this x canceled out. So we have a very simple linear equation. We get x equals 5. That will not cause any of these denominators to equal 0, so there's no extraneous answer. And we're done with number 2. So let's look at 3. Okay, so you might see here that we're pretty much already factored, so we need a 2 and an x squared, so our LCD is 2x squared. So we're going to multiply all the way across by 2x squared over 1. So this cancels, so we have 1. Here the x squared cancels. Now we have to distribute that 2. So 2x squared minus 14x plus 12. And here one of the x's cancels, so we have plus x. So this time we have a quadratic equation, so we want to set it equal to 0. So I'm going to subtract this 1, and we'll combine those like terms. So we have 2x squared minus 13x plus 11 equals 0. So I'm going to factor this using the a times c method. So a times c is going to be 22. So that would be negative 2 and negative 11 are the factors of 22 that add up to be negative 13. Remember, we split this middle term into 2 pieces using our 2 factors. And we want to write this with a plus here, plus a minus, and we're going to factor by grouping that we just had in the last unit. So we can factor out a 2x here, and we're left with x minus 1. And here we can factor out a negative 11. And now we pull together our factors by factoring out the common binomial, and the leftovers are 2x minus 11. And now we use our zero product property and set each factor equal to 0, and we've got x equals 1, and here we get x equals 11 halves. Now we check each of these to make sure in the original problem that it won't cause a divide by 0. So if I put a 1 here, that won't cause 0, so that answer is good. And if I put negative 11 halves in our denominators, we also don't get 0, so both answers are good. So we have two solutions for this equation. And now our final example we have, this one will end up having a extraneous answer so that we can demonstrate that. So again, our denominator here factors into x times x minus 3. We can GCF factor out an x. This is already factored. And here again, we can factor out an x minus 3. So our unique factors, we have an x and x minus 3. So that's our least common denominator. So again, let's multiply every term by our least common denominator. And here I like to put my binomials in parentheses so that when we multiply, we remember to distribute as appropriate. Oops, that's a times. So here we cancel everything in the denominator. We have an x plus 1. Here the x minus 3 cancels, so I've got to distribute this x. So we've got plus 2x squared minus 2x. Here everything cancels, so we have a 1. So again, we have a quadratic equation. I'm going to combine like terms on this side of the equation. We want to make it equal to 0. And we're going to solve by factoring. So we can factor out an x. And using the zero product property, we get two solutions, x equals 0 and x equals 1/2. Now, if we put 0 back into the original denominator, it's going to cause this denominator and this denominator to equal 0. So this answer we're going to throw out. It's extraneous. Now, you don't have to write that word. I'm just writing here that the reason we cost it out is because it's extraneous. If I put 1/2 into the denominator, it won't cause that to be 0. It won't cause that to be 0. It won't cause that to be 0. So we have one solution. So that's it. You can see that we've turned these kind of terrifying looking equations with all the fractions into simple linear or quadratic equations, and the whole key was multiplying by the LCD over 1. So best of luck with solving your rational equations, and don't forget to check out for the extraneous. See you around.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready?